So I thought I'll be able to start your classes not in online mode, face-to-face classes by July, June end or July. But I don't think uh, this semester, maybe for the next 2 to 3 months, I will be able to see you in person. So anyway, I am going to record all the classes for uploading in Moodle. So I thought if you are able to join, you can join. I was keeping all the tougher portions for the face-to-face classes, but I don't think we won't be able to do it. That face-to-face classes we will do Google Meet and record it and upload it in Moodle. Today's class it is will be with respect to botanicals. You have seen all the materials you have given that written assignment also. The next class will be on organophosphorus insecticides. After that, it will be on this one synthetic pyrethroids. Then we will go for neonicotinoids. In between, after completing organophosphates and synthetic pyrethroids, we will be discussing about the mode of action of organophosphates and synthetic pyrethroids. So these three organophosphates, synthetic pyrethroids, the mode of action of organophosphates and synthetic pyrethroids, the material is uploaded in the Moodle. You can check the Moodle, go through it. You can see several videos are also uploaded. See that videos, especially for mode of action part, so that the classes will be more clear to you. So I think Sri Lakshmi has lost her connection. Anyway, I am continuing with the class. So botanicals, it's an easy part. Class wise, it is a bit easy to study also. I won't be dealing much in detail. I will be discussing only in a small part with respect to botanicals, which are the major botanicals which is currently used in agriculture. Can you see the slides?
Yes, sir.
Are you able to? Yes or no?
Yes, sir.
Yes. Okay. Fine. So the botanicals, as the term botanicals indicates, these are any material obtained from plants. Whatever the material which we extract from plants and use it for plant protection, crop protection, all those things are called as botanicals. Sometimes we use oils such as neem oil, sometimes for pongamia oil. All these oils are used. Sometimes water extracts, extracts are used. A typical example is neem seed kernel extracts, wherein we are not using the oils. We will just steep all the powdered neem seed kernel in steep all those things in water and use the water extract. So these way, whatever be the chemicals which we extract from plants or plant material, if you're using it for plant production, they call it as we call it as botanicals. And these are one of the most widely used age-old plant protection product. This was used from first century AD in China, India, Greece, Egypt, etc. And in those times, the most common one used was neem. Obviously, it is in India. In our country, neem was the major botanical used for plant protection. And pyrethrum not in our country because pyrethrum the crop is not grown in our country widely. Then we used certain countries use rotinol, and nowadays essential oils are becoming more and more. But essential oils are also were also used previously also different centuries before also essential oils were used for pest management. But nowadays essential oils are gaining more and more importance in among the botanical group of pesticides. And other than neem, pyrethrum, rotenone, and essential oils, rhynia, nicotine, and sabardilla are also used to some extent. Nicotine, though in our state, tobacco decoction is recommended for plant protection. Rhynia and sabardilla, it's not used here, but in areas where these plant materials are available, they are used to a lesser extent. It doesn't have that much insecticidal property, but nicotine is having good insecticidal property. And because of the inherent resistance power of a group of plants, each and every plant will have, you might have studied about secondary plant metabolites, antibiosis and all in the case of resistance to insect pests by crop plants. The crop plants resist, a typical example I will suggest is, take the case of any cucurbitaceous vegetable. All these cucurbitaceous vegetables contains a secondary metabolite plant compound called as cucurbitacin. You might have studied. This cucurbitacin, those pests, insect pests which is feeding on cucurbitaceous vegetables has the ability to digest cucurbitacin. Has the ability to feed on cucurbitacin because evolutionarily these insects has evolved a mechanism to feed on plant material containing cucurbitacin. But those insects which are not feeding on cucurbitaceous vegetables will be susceptible for cucurbitacin. That means if you take an extract from cucurbitaceous vegetables containing cucurbitacin, and if you say spray on any say cowpea, the cowpea pod borers, which are not a pest of cucurbitaceous vegetables, may find it repelling or anti-feedant property of cucurbitacins. Because cucurbitacin, it's a secondary metabolite. The cowpea pod borer are not used. Pod borers are not used to such a chemical, so they won't be able to feed on any crop sprayed with any other plant metabolite which are not exposed to them. Another typical example is cruciferous vegetables, say diamondback moth. Diamondback moth feeds only on cruciferous vegetables, and they can feed on the certain. I forgot the chemical in cruciferous vegetables. That chemical it can feed on, but other insects, say cowpea, aphid, and all, it may not be able to feed on these cruciferous vegetables. And if you take an extract from cruciferous vegetables and spray it on cowpea, we will be able to manage to some extent. I'm not saying it may have extremely good activity. To some extent, it can control the cowpea aphid. But a typical exception to all these examples I have given is polyphagous insect pests. Polyphagous insect pests such as Spodoptera, Helicoverpa, etc. You can see that it feeds on cowpea. It has the ability to feed on cucurbitaceous vegetables. It has the ability to feed on cruciferous vegetables. Okay. So these polyphagous insects has developed the ability to feed on plants containing diverse secondary metabolites. Take another example, a typical example I used to suggest is tea mosquito bug, Helopeltis antoni. We say that neem, it is having excellent insecticidal property, repellent, anti-feed, so many properties. But we have seen Helopeltis antoni, a tea mosquito bug, feeding on neem tree because it has evolved the ability to feed on neem. So those plant metabolites may be a repellent to some species, but it may not be a repellent or anti-feedant or having insecticidal property to the pest which feeds on that particular plant. Say a pest which is feeding on banana, if you take the extract of banana and try to spray it on that pest itself, it won't get repelled. It won't have any anti-feedant property because the insect has the ability to detoxify that secondary metabolite present in banana. But take some banana extract and try to spray on rice. At least to some extent, it may have some impact on the insect that's feeding on rice crop. So that's the way every plant is having some secondary metabolite. Secondary metabolite means in the cucurbitacin, azadirachtin, all are secondary metabolite. Any chemical produced by the plant system itself. So these secondary metabolites has one or the other properties against insects. So if it scan all the plants present in our earth, almost all the plants are having one or the other insecticidal property. So over 2000 plants are identified to have one or the other insecticidal property. Though the use of botanicals is limited, in the global pesticide scenario, approximately 6% of the pesticide use is with botanicals. So we have a steady market for botanicals globally. In our country also, botanicals are having very good market share, not as that of synthetic chemicals, but it is having a sizable share in our Indian market too. And major, almost 99% of that market is occupied by neem-based products. So, botanicals as such is used from time immemorial, and the major botanicals nowadays used are neem, then pyrethrum, rotenone, and essential oils. And many plant species are having chemicals which are having insecticidal property. And globally, we are having about 6% of the pesticide use is with botanicals. And coming to advantages of the botanical, that you may all know, it has low mammalian toxicity. That it's extremely known to you. Very low mammalian toxicity is there with most of the botanicals, and it's have very low environmental pollution. Sometimes we can say it doesn't have any environmental pollution at all, because all these are naturally derived material, and the stability of these naturally derived materials are extremely low in environment, in outside environment. Take a typical example we can say is that of neem. It won't persist, the effect won't persist in the crop for more than 2 to 3 days. That's why if you are going for pest management, any neem-based pesticide, we have to go for repeated application of neem-based pesticide. Usually we recommend farmers to go for weekly application of neem-based pesticide because it doesn't have any persistence at all. So the chances of environmental pollution is almost nil. And if you see the case that we are taking a neem seed kernel extract or neem oil emulsion, it doesn't contain azadirachtin. Don't think that it contains azadirachtin only. It contains number of molecules, and all these molecules are having pesticidal property. So the pesticidal effect of neem is not due to azadirachtin alone. If you take azadirachtin itself, it's not a single molecule azadirachtin. We have about 10 or 12 kinds of azadirachtin. We usually name it by giving a suffix of alphabets. Azadirachtin A, we usually say it as asa A. We have azadirachtin B, we usually abbreviate as asa B, asa C, asa D, asa E, asa G, asa H, asa F. So we have different types of azadirachtin, and it's not a single molecule. We call it as all as azadirachtin, but it's not a single molecule. We have several molecules. In addition to azadirachtin, we have several molecules which are having pesticidal properties such as nimbin, selenin, etc. So usually, a botanical is having several pesticide molecules. In the case of nicotine or tobacco, we have pesticidal molecules. We usually say it is containing nicotine. The pesticidal molecule is nicotine. Other than nicotine, it contains nornicotine, anabasine, etc. All these molecules are having pesticidal property. So the chances of development of resistance to a botanical is extremely low, because an insect, it is easy for an insect to develop resistance to a single molecule. But if that pesticide product is having numerous molecules, the ability of the insect to develop resistance to these numerous molecules is extremely low, or it is very difficult for that organism to develop resistance to numerous pesticide molecules. So, the chances of development to a botanical which contains innumerable pesticidal molecules is extremely low, and the chances and the toxicity to non-target organisms is extremely low. But this statement can be contested. You have seen Poitravumar is working on the toxicity of insecticides as well as botanicals to coccinellid predators of aphids, and the highest toxicity it was observed with neem oil emulsion or neem seed kernel extract. Anyway, neem-based products are having high toxicity to predators. So this statement, it's not true always. These botanicals can also have some toxicity to non-target organism, and it may not have adverse effect on plant growth. Again, it's not true always, because if we are not emulsifying neem oil properly and spraying it on a crop, it can lead to toxicity. So the though generally the plant products may not have any adverse effect, sometimes if you are not using it properly, especially oils and all, it can lead to phytotoxicity. And another advantage is that it is less expensive. It's not always so, especially with the case of essential oils. Essential oils are extremely expensive in nature. And neem also, it's not that cheap. If you have some neem plants in your homestead, yes, it's okay. You can use the neem seeds available in your homestead. But otherwise, if you want to purchase it, the cost is almost similar as that to other synthetic chemicals. So if you see the advantages, it has low mammalian toxicity, it doesn't cause any environmental pollution, the chances of development of resistance is low, it has low toxicity to non-target organism, and it doesn't have show an adverse effect to plant growth, and it is less expensive. Though certain things, certain statements, it may not be true always, like low toxicity to non-target organism, no adverse effect on plant growth, less expensive, etc. In some cases, it's not true. And if we compare botanicals as well as synthetics, in what are the major differences between a botanical pesticide and a synthetic inorganic pesticide, a synthetic organic pesticides? First, we will discuss about the active ingredient. As I told you, the botanical pesticide, say neem seed kernel extract or a neem oil emulsion, contains number of secondary metabolites, number of chemicals, and each may be having pesticidal property. And the concentration of active ingredient may be extremely high. Say neem contains very high quantity of acyl directine. But in the case of synthetic pesticide, usually most of the pesticide molecule, pesticide formulations are having only single active ingredient, and sometimes we may have two pesticide mixtures and all, and they may have a specific mode of action. Say if you are having an organophosphorus pesticide, it is having acetylcholinesterase inhibition. If we have a neonicotinoid pesticide, it will have nicotinic acetylcholine receptor modulators. But in the case of botanicals, it can have diverse mode of action. If you see the neem itself, it can have antioxidant activity, it can have growth regulatory activity, it can have repellent activity, it is maybe sometimes insecticidal properties also. So botanicals can have a single plant material, can have diverse mode of action, but synthetic pesticides usually contains one, maximum two active ingredient with specific mode of action. And usually the concentration used is extremely low. Take a typical example. Do you know what is the commonly used concentration of neem seed kernel extract? Anyone? What is the concentration of neem seed kernel extract usually we recommend to farmers? Anyone? 5%. That is 5%. It
Five
is five
percentage.
percentage. Do you know the what is the usual percentage of organophosphorus pesticides, chlorpyrifos? Usually we recommend it to farmers.
Two.
Any idea? It's not two. No. It's usually 0.05. See the difference? In the case of neem seed kernel extract, we are preparing a 5% insecticidal material, while synthetic organic pesticides we are spraying at a concentration of 0.05 and all, and in new generation molecule it comes down to 0.0001, etc. So we usually use very low concentration of active ingredient. So if you compare the active ingredient of botanicals and synthetic pesticides, botanical contain number of active ingredient, and it can have diverse mode of action. and whatever the botanical we use, usually we use it at a higher concentration. While synthetic pesticides, it may be having, usually it will be having one active ingredient, it may have two, and this pesticide has specific mode of action, and the concentration used for pesticide application is extremely low. And coming to the manufacturing of botanicals and synthetic pesticides, botanical pesticides can be manufactured pretty easily. A typical example is, take the case of preparation of neem seed kernel extract. We will take the neem seed, powder it, keep it and soak it in water for 24 hours. We have extracted the botanical pesticide. But take the case of synthetic pesticide. We need to have heavy machinery. We have several steps, chemical manufacturing steps to synthesize the active ingredient. So, in botanicals, the preparation is pretty easy, but synthetic pesticide, the manufacturing is involves several steps. And coming to the scalability of botanicals and synthetic pesticides, that means how we can manufacturing it in large scale. That is one of the major limiting factor of botanicals. If you want, if you have found out a very good plant material which is having very good insecticidal property, if it needs to be scaled up, that means if you want to synthesize it in large quantity, you need large quantity of biomass of that plant material. That means take neem. Why it became so extremely popular botanically in our country? Because neem seed, neem trees are available in plenty in most parts of our country, except in Kerala, which we have very high rainfall, so neem doesn't come up nicely in our state. But in other states, Tamil Nadu, Karnataka, Andhra, and all, the roadsides will have innumerable number of neem trees. Every backyard may have large neem trees, huge neem trees, and it will yield every year. It will give huge number of huge quantity of neem seeds. So the biomass is available in plenty. From this neem seeds, we can go for extraction of azadirachtin, we can go for neem oil extraction, etc. But if the plant material is limited, we take the example of pyrethrum. Pyrethrum is available from a flower of tenacetium, a plant called Chrysanthemum cinerarifolia, which is also called as Tenacetium cinerarifolia. But it can be grown only in certain areas. So the availability of chrysanthemum flowers is extremely low, and the cost of pyrethrum is extremely high because of the limited availability of pyrethrum flowers. So the availability of biomass is a critical feature for the scalability of botanical pesticides. But in the case of synthetic pesticides, there is no issue with scalability. If we have the raw material, we can manufacture it in as much quantity as we can. So that is one typical difference between botanicals and synthetic pesticides. And regarding shelf life, that you all know, if whatever the botanical you prepare, you have to use it within 24 hours, otherwise it will degrade. While synthetic pesticides, usually it have a shelf life of 1 year. So that's the difference. Botanical pesticide, the shelf life is 1 day, but synthetic pesticide, it is almost 1 year. Another difference is the production cost. The production cost for botanical pesticide, it vary depending upon the availability of the biomass. Neem, it is cheap because we have the biomass is available. Pyrethrum, because of the low availability of chrysanthemum flowers, the cost is high. While in the case of synthetic pesticides, for off-patent molecules, that means those products which are not in the patent regime, such as malathion, quinalphos, ecalex, chlorpyrifos, etc., the cost is extremely low. A liter of chlorpyrifos costs less than 250 rupees. So the cost is extremely low for synthetic pesticides. Patented molecules, the cost is extremely high, say chlorantraniliprole, chlorantraniliprole, florbendamide, etc. The cost is high. But off-patent molecule, the cost is extremely low. And in the case of application of these pesticides, synthetic pesticides, it is used in all sector, agriculture, medical, veterinary, storage, wherever situation, in urban situation too. Urban situation, I will take the example of mosquito repellents. The synthetic pesticides are used in urban scenario, in medical situations. This pesticide for head loss management and for destroying head loss, we use chemical pesticides. Storage pest management in forestry, in whatever be the scenario in veterinary, widely used synthetic pesticides are widely used. But in the case of botanical pesticides, the applications are limited, especially in the case of certain urban scenarios. Say, take the case of lemongrass oil and all. It is used for repelling houseflies. In medical, again, I took the example of head loss and synthetic pesticides. In medical field also, these botanical pesticides are used for head loss management. Storage, botanical pesticides are used, but most widely used is synthetic pesticides. Forestry, mostly it is botanical pesticides only. Synthetic pesticides are very rarely used. Synthetic pesticides are usually used for treatment of timber. Then for large scale agriculture also botanicals are used, but whatever be the sector, the application is extremely limited. But synthetic pesticides, it is widely used in all pest management sector. And regulatory hurdles, how to register a pesticide. Almost synthetic pesticides and botanical pesticides, the registration requirements is almost the same. Though we say that botanical pesticides are relatively safe, uh, uh, it requires full regulatory requirement compared to synthetic pesticides. And social hurdles, I would say most of the people consider botanical pesticides as safe and synthetic pesticides as harmful. But I took the example of neem, which is harming natural enemies. People don't understand that neem can have some adverse effect on natural enemies, but people usually consider it as a safe molecule. And coming to the marketing channel, it is mainly used in retail channels, the pesticide shops and all, and mainly with respect to small land holdings, household vegetable cultivation, homestead vegetable gardens, kitchen gardens, etc. It is widely used. Synthetic pesticides are used all over the agriculture sector. So if you see the difference between botanicals and synthetic pesticides, the combination of active ingredient, its mode of action, and its concentration, everything differs between botanical and synthetic pesticides. The manufacturing is pretty easy in botanicals, but it requires several steps in the case of synthetic pesticides. The scaling up of production of botanical pesticides is dependent upon the availability of biomass, but synthetic pesticide we can scale up as and we require. The shelf life is limited in the case of botanicals, but synthetic pesticide we have very good shelf life. The cost of production of botanical pesticides depends on the availability of biomass, but synthetic pesticide usually it is cheap. Botanical pesticides, it's a limited application, but it has wide application with the synthetic pesticides. Regulation, it is same for both. People usually consider botanicals as safe, but synthetic pesticides are generally considered harmful. And it is marketed mainly in retail channels and limited scale in the case of botanical pesticides. Coming to the first botanical, that is neem. As you all know, it is derived from neem tree, that is Azadirachta indica, belonging to the family Miliaceae. And for plant protection, for pest management purpose, we use two parts of neem. One is neem oil, and the second one is neem seed extract. Neem oil is non-polar fraction. It's oil means it's non-polar fraction. Oil it gets doesn't get dissolved in water. So water is an extremely polar molecule. So neem oil, it is not insoluble in water. So it is a non-polar fraction. And there is this neem seed extract. We keep it in water. And whatever be the extract what we get in water is polar fractions of neem. In neem oil, we get non-polar fraction. In neem seed kernel extract, we get polar fraction because neem oil is insoluble in water. That's why we emulsify it with soap. Otherwise, it won't mix properly with water. So it is having non-polar fractions of neem. While neem seed kernel extract, we prepare it in water. Hence, it is the polar fraction of neem-based pesticides. And the major active ingredient is azadirachtin. I told you about azadirachtin. We usually abbreviate it as ASA, and it is polar fraction. That's why if we keep neem seed kernel powder in water, what we normally get is azadirachtin. And in neem oil, a certain portion of azadirachtin will be there, but it's not mainly azadirachtin. It contains several other pesticide molecules that we will discuss later. And azadirachtin, as I told you earlier, it's not a single molecule. We have more than a dozen azadirachtin analog. I told you azadirachtin A, B, C, D, E, F, G, etc. So we have a several dozen azadirachtin analogs, but the major one is azadirachtin A. In addition to azadirachtin, neem contains several other pesticide molecules. They are terpenoid group of secondary metabolites such as nimbin, salanin, nimbidin, and meliandriol. Only a few list. It contains several pesticidal molecules. Almost all of them have pesticidal properties. I have given only examples such as nimbin, salanin, nimbidin, meliandriol, etc. And neem seed contains roughly 0.2 to 0.6% azadirachtin. The content of neem seed varies widely, so we can't say standard neem seed contains say if you take neem seed it will contain say 0.5%. We can't say it like that because it varies widely, and it not only seeds. Azadirachtin is also present in neem leaf, bark as well as fruit, and the LD50 is more than 5. That's why it is having green label, and it is having some systemic property also. Usually we consider neem as having contact oxidity, but it is having slight systemic properties too. So neem, as you all know, it is from Azadirachta indica. We usually use neem oil, the neem non-polar fraction, or the polar fraction, that is neem seed kernel extract. Mainly contain azadirachtin and its several analogs. It also contains other pesticidal molecules such as nimbin, salanin, nimbidin, meliandriol, etc. Usually neem seed contains 0.2 to 0.6% azadirachtin. It is almost safe. The L50 is greater than 5000 milligram per kg body weight, and it is having some systemic properties also. Coming to the mode of action of azadirachtin or neem, it is having several mode of action. The first mode of action is insect growth regulatory activity. We call abbreviated as IGR, and that means it can affect the proper growth of insects. It is having anti-fident property. That means if you spray azadirachtin or neem-based pesticides on a crop, insect won't be able to feed on it. And another property is repellent property. You should understand the difference between a repellent and anti-fident. Anti-fident means insect will come and rest over the sprayed plant surface, but insect won't be able to feed on that sprayed surface. While repellent means that insect will be repelled away from the plant surface itself. Insect won't settle in the crop itself. If the pest settles on the crop, it doesn't have any repellent property. If it insect doesn't settles on the crop, it has repellent property. Once it settles, and if the insect is unable to feed on that sprayed crop, that botanical is having anti-fident property. I think the anti-fident and repellent concept is clear to you. Repellent means insect won't be able to sit on that sprayed crop. If you spray some neem-based pesticide on, say, chili, if there is whitefly won't be able to come and sit over it because of the repellent property. But if neem doesn't have any repellent property and it is having only anti-fident property, that means whitefly will come, sit under the leaf, rest under the leaf, and once it starts try to feed on the suck sap from the leaf surface, because of the antioxidant property it won't be able to suck the sap. So that is antioxidant property. Repellent property, it repels the insects away from the sprayed surface. Next is oviposition deterrent. That means the insect won't be able to oviposit on the sprayed plant surface. And sometimes this neem is having direct toxicity. That means if you spray neem on a pest, it can lead to the mortality of the insect, but it is extremely limited, and it is having some ovicidal property. That means if it falls over the eggs may not hatch. It has sterilant property. That means it can make the insect sterile, and it can affect insect vigor, longevity, and fecundity. That is one particular feature with botanicals. Even though if we go for spray of a botanical, we may not see any mortality of the insect, we may not see any antifoedant property or repellent property, but it can affect the insect vigor, it can affect the lifespan of the insect, and it can affect the fecundity of the insect. So that is one particular feature with many of the botanicals. It is there in neem, it is there with other botanicals also. So for neem, we have diverse mode of action such as IgR, antifoedant, repellent, oviposition deterrent. It can have direct toxicity. It can have ovicidal property. It can sterilize the insect, and it can affect the longevity, fecundity, and vigor of the insects. Coming to the next plant, this plant also belongs to the family Meliaceae. It is called as Persian lilac. The scientific name is Melia asadrac. It's not common in our area, but it's present in our country. Again, it is containing triterpenoids. The activity is almost similar to neem. Contains triterpenoids called as meliacarpins. The antifoedant or the insecticidal molecules are called as meliacarpins. Mainly, these are feed and deterrents, and it is having some stomach poison properties also. So, Melia asadrac contains meliacarpins, which is having feeding deterrent and having stomach poison properties. Next is pyrethrum. Pyrethrum is one of the age-old botanical used from flowers of a plant called as Tenacitum cinerarifolium. You might have studied it as Chrysanthemum cinerarifolium. The genus name is changed to Tenacitum cinerarifolium. It is this pyrethrum having uh, two acids and three alcohol. We will discuss about the acids and alcohols when we discuss about synthetic pyrethroids. Just remember that pyrethrum consists of esters of two acids and three alcohol. So we have pyruthric acid and chrysanthemic acid as the two acids, and we have three alcohols, that is pyrothrolone, cinnarolone, and jasmolone, and we have six esters. These pyruthric acid and cinnaric acid can react with these three alcohols, and it can form six kind of esters: pyrethrin 192, cinnarin 192, and jasmolene 192. So we will discuss about it later when we discuss about synthetic pyrethroids. I am not discussing it over here. Just understand that the pesticidal molecules are esters of two acids and alcohols. These esters are pyrethrin 1 and 2, cinnarin 1 and 2, jasmine 1 and 2. I will discuss about all this when we discuss about synthetic pyrethroid. And all these are having rapid knockdown action. This rapid knockdown action, if you have take the example of mosquito repellents. About 10 to 15 years back, when you were using your mosquito repellent coils or vaporizers in your home, you can see that mosquitoes will fall on the tables and floors just as these have fainted upon. തല കറങ്ങി വീഴുന്ന പോലെ these mosquitoes will usually fall over the table surface once we use mosquito repellents. Nowadays we don't see it because the mosquitoes have evolved resistance to this. This is what is called as rapid knockdown action. That means it will fall as if it is knocked down. ഇടിച്ചു വീഴുന്ന പോലെ വീഴും. And it is acting just as synthetic pyrethroids. It is having acting on voltage gated sodium channels. But the major problem with the natural pyrethrum is that it is highly photolabile. That means it degrades under sunlight. That's why we have evolved synthetic pyrethroids. Understand the difference between the terminology. The natural material, it is called as the pyrethrum, and the synthetic material, we call it as pyrethroids. Understand the terminology. I will repeat again. The natural material, the pesticide molecule derived from the flowers of tenacitum, that is called as pyrethrum. But if we go for artificial synthesis of these molecules, we call those molecules as pyrethroids. Pyrethroids doesn't contain the natural pyrethrum molecules. So This is the difference pyrethrum and pyrethroids. Understand the difference usually in interviews and vivas. This is all. What's the difference between pyrethrum? You can invariably say that pyrethrum it is derived from natural flowers of chrysanthemum, but pyrethroids these are synthesized artificially. So the esters and all we will discuss later. Coming to the next essential oils, and all over the world in the botanical pesticides, essential oils are gaining more and more importance because some persons think that essential oils will be the major part of botanical pesticides in pest management, overcoming maybe neem. And essential oils are those which are obtained by steam distillation of aromatic plant. A typical example I will suggest is lemongrass oil. You might have studied in your UG course. If we distill lemongrass oil, citronella oil, we'll get aromatic essential oils. And these essential oils all are having pesticidal properties. If you see the chemical composition of essential oils, it mainly contains monoterpenes. Monoterpenes is a group of chemicals. We have phenols and we have sesquiterpenes, and these most of the whatever chemicals I am discussing, most of them are monoterpenes. Most of the essential oils contains chemicals such as 1,8-cineol. This is 1,8-cineol. This 1,8-cineol is mainly present in the essential oil of rosemary, Rosmarinus officinale, and in eucalyptus. That means eucalyptus oil, the major essential chemical present is 1,8-cineol. And in clove, Syzygium aromaticum, the major chemical present is eugenol. Again, it is a monoterpene. In thyme, Thymus vulgaris, in plant, in the thyme plant, we have the essential monoterpene thymol, and from mentha we have menthol. From acorus we have beta acerone. Hasina teacher is now working with acorus, and madam was telling acorus is having very good activity against mites. So we have essential oil yielding plants numerous. I have given only a very in a limited list. If you see the literature, we have a huge number of plants yielding essential oils, and all these plants contain several pesticidal molecules. Most of them are monoterpenes, and many and these examples of monoterpenes include 1,8-cineol, eugenol, thymol, menthol, beta-acerone, etc. And if we see the mode of action of this essential oils, most of these essential oils are having fumigant property. That means if it the typical feature of an essential oil is it vaporizes in atmospheric temperature. That means if we keep essential oils outside, it will release the vapor and the quantity will decrease. It will release the vapors into the atmosphere. And if you keep the essential oil in a closed structure, and if you release the insects will die of fumigant properties of essential oils. Another typical feature for essential oils is it is having some contact insecticidal property. That means if you spray essential oil over an insect, it can lead to the mortality of the insect. It also have, if you see literature, you can see that the essential oils act on octopamine receptors and GABA-gated chloride channels. So the site of action of essential oils can be octopamine or GABA-gated chloride channels. We can't say that all essential oils are acting on GABA-gated chloride channels. If you scan the literature, you can see that uh, several essential oils, most of the essential oils act on GABA-gated chloride channel, and some are acting on octopamine receptors. But the major disadvantage with essential oils is that it is having very low persistence. I told you at room temperature, it will vaporize quickly. So its persistence is extremely low, and it can lead to some adverse effect on pollinators and natural enemies because it can have fumigant properties against pollinators and natural enemies. So essential oils, though the major advantage is its low persistence. Low persistence can be an advantage and a disadvantage. Take the case of vegetables, say cowpea, which is harvested every alternate day. Any pesticide use should have low persistence, otherwise it will have residue. But say a crop such as banana and all, it is standing in the field for 10 months. If it is extremely low persistent, it is a disadvantage and it can affect pollinators and natural enemies. That is with respect to essential oils. Then we will discuss about rotenone. Rotenone is widely used as a fish poison. I don't know whether it's a practice in other areas, but in our area locally, we used to use certain plants. ഞങ്ങളുടെ നാട്ടിൽ പറയും നഞ്ച് കലക്കുക എന്ന് പറയും. We used to crush certain plant material and add it to water bodies, ponds, etc. If we add it to that water bodies, these plant materials are having high fish toxicity and all the fish will die. And rotenone is one such fish poison which was used for very long time, and it is mainly available from plants such as Deris, Longocarpus, Tephrosia, and roots and rhizomes of Deris, Longocarpus, and Tephrosia contains flavonoids such as rotenone, degulin, ellipton, sumatrol, toxicarol, and malacol. All these are having insecticidal property, but the major chemical which is having insecticidal property is rotenone. So rotenone is obtained from the roots or rhizomes of plants such as Deris, Longocarpus, and Tephrosia, and the chemically these are flavonoids. Other than rotenone, we have degulin, ellipton, sumatrol, malacol, and toxicarol, and it is acting on the electron transport chain, mitochondrial electron transport chain, and prevents the synthesis of ATP. Its LD50 is extremely low because it is toxic to human beings also, and it is not widely used in pest management. It is acting on electron transport chain. Coming to next botanical, that is Sabardilla, it is also not widely used. It is obtained from seeds of a plant called Stenocolon officinale, and it contains other than Sabardilla, we have Cevadin and Veratridin, other pesticidal molecule. It's also extremely toxic. It is LD50 is 13 milligram per kg. So Sabardilla is obtained from Stenocolon officinale from the seeds. Other than Sabardilla, we have Cevadin and Veratridin, which are pesticidal, properties. Next is Rhinia. It is from the plant Rhinia speciosa. The major constituent is rhinodine. Now you can remember the mode of action of diamide pesticide. It acts on rhinodine receptors. Rhinodine receptors are located in muscles. So its action is similar to diamides. That's why that receptors are called rhinodine receptors. These receptors were first identified using the poison rhinodine, because scientists, when used rhinodine, they found that it affects calcium release in muscles. Hence, that receptors are called as rhinodine receptors. And diamide pesticides are acting on the same rhinodine receptors, and it is having contact and stomach poison. Again, just like Sabardilla, this one is also not widely used. And nicotine, this is used to some extent. As you know, it is obtained from tobacco, Nicotiana tobacco. I told you earlier, it contains other pesticide molecules other than nicotine, such as non-nicotine and anabasine. It affects on nicotinic acetylcholine receptors. We will discuss about the mode of action of nicotine when we discuss about neonicotinoids. Again, it is having extremely high toxicity to mammals. LD50 is 50 milligram per kg. Certain practitioners of organic farming say that nicotine can't be permitted in organic farming because it is a carcinogenic molecule. And pure nicotine, it is used as a fumigant in greenhouses because it is extremely short-lived. This nicotine does not persist in the environment at all. If we discuss about the preparation of tobacco decoction with our head Manijallapan sir, Manijallapan sir will always tell, if you are preparing tobacco decoction, use it immediately. If we keep it for some time, its activity is lost. So it is extremely short-lived, and we have we synthesize nicotine sulfate from nicotine, and it is used as a sprayable pesticide. It is banned in our country, but nicotine sulfate is manufactured and it is exported from our country. but it is not used permitted for use in our country, and it is all effective against soft-bodied insects. That's why it is recommended for the management of aphids, especially in cowpea and all. So nicotine, other than nicotine, we have nornicotine and anabasine acting on nicotinic acetylcholine receptor, high toxicity to mammals, is used as a fumigant, and nicotine sulfate is sprayed on crops for management of soft-bodied insects. Another one is currant, that is from Pongamia pinnata. This currant oil, Pongamia oil. The active component is carrageen. It is mainly used. The Pongamia oil is available from Tamil Nadu. It is widely used in Tamil Nadu. It is an antifeedant as well as a repellent. It is its oil as well as oil cake is having pesticidal property. Usually we use Pongamia oil, but Pongamia oil cake is also having pesticide property, antifeedant and repellent property. Main component is carrageen. And the next botanical is Annonaceous acetogenins. This is mainly, as the name indicates, it is obtained from Annona, seeds of Annona. See here the scalability of this technology. The quantity of, you might have taken Sitafal and all, Annona. If you can see, it contains very little quantity of seeds, and we are trying to extract a botanical from seeds of Annona, and the seeds of Annona itself is extremely limited, having limited availability, and even if you get a fruit, the quantity of seeds is extremely low. So the scalability of this technology is extremely low, and it contains pesticidal molecules such as annonacins, and annonidins, but it is having some cancerous properties, and it is not recommended for use in agriculture. It affects energy production in mitochondria just like rotenone. It is extremely toxic to mammals. It is having pesticidal properties. Several work has been done with annonacins, and annonidins, but it is having some cancerous property, so it is not widely used. It is toxic to mammals. And I'm stopping the discussion about botanicals, and I will quickly go through why botanicals. Though we have said in the introductory part, we have said that we have about more than 2,000 plant material which is having insecticidal molecule, and then why it is not being able to commercialize it just like a synthetic pesticide. One thing is the sustainability. That means the plant material, the plant biomass should be obtained in large quantity that we have discussed. Take the case of Annona itself. And another thing is we for obtaining plant material, either we may have to go for cultivation of the plant, just like tobacco and Annona. For getting the pesticidal molecule, either you have to go for it may not be obtained in wild. Annona seeds we won't get in wild, just like neem seeds. Normally, no one goes for cultivation of neem. We get naturally. We we have wild growth of neem all over our country. So obtaining neem seed is not difficult in our country. But take the case of tobacco and Annona. If you want to go for nicotine, you have to cultivate tobacco. Tobacco won't be available in natural situation. Annona, you have to go for cultivation of Annona. But it is difficult for cultivating these crops in large scale only for pesticide extraction. Otherwise, we may get it as a byproduct. In tobacco and Annona, usually what people do is the waste tobacco products, tobacco material is used. And another potential source is go for genetic engineering of existing crop. I will say the example is identify the gene which codes for the production of azadirachtin. I will give an example as neem itself. We can understand that as there will be some genes which are responsible for the production of azadirachtin in neem tree. You isolate that gene and introduce that gene in rice or any vegetable, etc. So what will happen? Rice plants will start producing azadirachtin. Theoretically, it is fine, but practically, it is difficult. So, if that works out, the rice will be producing azadirachtin. It will be able to repel plant on its own. And once the crop is harvested, you can use rice and you can use the straw for extraction of azadirachtin. That is one option. But the major problem is that azadirachtin is extremely bitter. Whatever the rice you harvest from that crop containing gene of azadirachtin, your rice will also be bitter in nature. So this is one option. Theoretically fine, but practically a bit difficult. So the sustainability of this technology is limited. That's why botanicals are not getting commercialized as a synthetic pesticide and standardization. I told you when we discussed about the content of azadirachtin in neem seed, we are given a range of zero point 0.2 to zero point 0.6. We have an extremely good paper from IRA that was authored by Dr. B.S. Parmar, and that paper they analyzed the azadirachtin content from neem seeds collected from different parts of the country. They collected seeds from different parts of the country, and they collected seeds during different seasons also. Usually it is available in monsoon, and it is they collected from different seasons also, and they found that there is huge variability of azadirachtin content if we collect it from different geographical locations. So even though we say that 5% neem seed kernel extract it is effective against lepidocaterpillars, we can't say that this 5% neem seed kernel extract will be having this much azadirachtin, because depending upon the area from we are collected the neem seed, the azadirachtin content varies. So standardization is extremely difficult. The same thing applies to other organic preparations. Say take the case of Panchagavya, Jivamrita, etc. The standardization of that thing is extremely difficult. We can't say that this will contain this much molecule. Why then neem products have extremely gained importance is that scientists has evolved techniques to extract azadirachtin, pure azadirachtin. So companies and research stations have the technology to extract pure azadirachtin from neem seed, and if we have pure azadirachtin, then we can synthesize a product containing this much concentration of azadirachtin. So that's how the standardization happened in neem products, but in other products that standardization is extremely difficult. And regulatory approval, though we say that it is safe, that mode of obtaining regulatory approval is extremely difficult. I became late for the class because a farmer came and he has a botanical product he has developed on its own, and it is containing neem oil, some garlic extract, and some plant material. That plant material he was not divulging the details of that plant, and he was trying to get registration for that molecule. We were discussing it for 1 hour just before your class. And the major problem is that for registration of a biobotanical pesticide, even though we consider it as safe, it is same as that of a synthetic pesticide molecule, and it is extremely cumbersome and costly. So farmers may not be able, a common man may not be able to go for obtaining registration of that botanical. So this is with respect to the botanical pesticides. If you have any doubts, you can ask anything. Anything else?
Yes, sir.
No, sir.
Okay. Okay, so before the next class, go through it. I will try to take it tomorrow itself on organophosphates itself. I will try whether 9:15, 9:30 will be convenient to you.
Exam.
Not
Tomorrow we
okay.
have exam.
At what time?
11.
11. Okay, we will take it in the
11.
afternoon.
Okay,
Yes,
sir.
sir.
Okay. Still you are writing exams?
First set.
Yes. Don't remind me.
Okay. Okay, fine. Okay, I'll take the organophosphates tomorrow. Okay, fine. See you tomorrow.
Okay.
Thank you, sir.
Okay.